Assalamualaikum and good day. We are group 4 from the instrumentation course BDA 21202 at UTSM. Today, we are pitching a product that addresses a parent's worst nightmare. I'm Haqimee, the project manager.
With Hong, the engineering manager.
And I, Arif, quality control manager.
I'm PHUA. I'm handling the hardware and calibration.
Hi, my name is YONG and I will be in charge for the simulation and design.
Let's talk about the problem. Imagine you are at a crowded mall or park. You turn away for just 10 seconds to check your phone or pay at the cashier. In the brief moment, your baby could be snatched from the stroller. Kidnapping and unauthorized removal of infants are a real danger. Traditional strollers have no security system. They are passive. So, our solution is the intelligent baby stroller safety system. We have applied industrial instrumentation principle, specifically weight measurement, to create a safety interlock that acts as an invisible guardian for the child.
Thank you, Haqimee. To solve this, we established clear objectives. First, to design a portable safety system using industrial instrumentation concept. Second, to use weight as our primary process variable. Why weight? Because unlike motion sensor, weight works even if the baby is sleeping perfectly still. Third, to implement signal conditioning using the HX711 amplifier and the ARDUINO Uno. Our fourth objective is to trigger embedded visual and audible alert the moment unsafe conditions are detected. This isn't just like a buzzer. It's critical to alarm system. Our scope was predefined. We focus on a standalone system powered by a battery. We calibrate the sensors to operate efficiently within a range of 0.5 kg to 10 kg, covering the weight of most infants in stroller.
For the simulation and design. When we are building the hardware, we have designed a block diagram that follows the standard industrial loop. Let's have a look.
Now, let's have a look for the block diagram. Firstly, the input, which is the baby weight. Secondly, the transducer, which is the load cell. Thirdly, the signal conditioning, which is the HX711 module. Then the processing, which is the ARDUINO Uno. And lastly, the output, which is the LCD, LED, and buzzer. Now, let's look for the simulation. This was a critical phase, so we created a virtual environment to test our logic without risking any hardware damage. Here you can see the virtual circuit. We simulated a drop in voltage to mimic the baby being removed. As you can see, when the virtual weight drops below the threshold, the logic pins goes high, triggering the alarm. This confirmed that our core logic was solid. This simulation phase minimized trial and error. We verified that the 24-bit ADC conversion logic was correct before we ever connect to a real wire. That's all from me.
Moving to the real hardware setup, we arranged the component systematically for reliable signals transmission. This is the screen guard slot cell. When the force is applied, the metal body deforms slightly, changing electrical resistance. It is robust and accurate. The signal from the load cell is tiny, in milliwatts. That is why we use this HX711 module. It amplifies the signal and converts it to digital data for the Arduino. Without this, the Arduino couldn't read the weight accurately. Finally, we have the Arduino Uno R3 as the brain. an LCD display using the 1-2C communication to show real-time status. We use a breadboard for this prototype to allow for easy calibration and adjustment.
I am Haris and as a Quality Control Manager. Today, I will demonstrate the system reliability. Since we cannot use a real baby, we are using this 1.25 kg water bottle to simulate the weight of a small infant. First step, initialization. Now, I am turning the system on. You see the LCD initialized, it can actually read 0.00 kg. The system is armed and ready. The second step is the safe state. I place the 1.25 kg bottle, which acts as a baby, on load cell. Now we can see the LCD shows weight 1.25 kg. The status is safe. This confirms the baby is present. Now watch what happens if I snatch this baby. Look, the buzzer is on.
The alarm triggers instantly. The weight drops below our safety threshold. This loud alarm alerts the parents immediately.
Good news! The results are consistent. During our testing, the system responded rapidly to sudden weight variation. The HH711 provided stable reading with minimal noise, proving the system is reliable for safety monitoring.
To conclude, this project successfully meet all objectives. We built a low-cost, high-reliability safety interlock for the stroller. We believe that this device can prevent kidnapping and give parents peace of mind. Thank you for watching our pitch. Thank you.
Terima kasih. Syukran jazilan.
Bye bye. Bye bye.